An axial piston pump has a number of pistons arranged in a circular array within a housing which is commonly referred to as a cylinder block, rotor or barrel. This cylinder block is driven to rotate about its axis of symmetry by an integral shaft that is, more or less, aligned with the pumping pistons, usually in parallel but not necessarily. One end of the cylinder block is flat and wears against a mating surface on a stationary valve plate. The valve plate has two semicircular ports that allow inlet and discharge of the fluid respectively. The pumping pistons protrude from the opposite end of the cylinder block. There are numerous configurations used for the exposed ends of the pistons, but in all cases they bear against a cam. In variable displacement units, the cam is movable and commonly referred to as a swash plate, yoke or hanger. The orientation of the cam, in combination with shaft rotation, provides the cam action that leads to piston reciprocation and thus pumping. The angle between a vector normal to the cam plane and the cylinder block axis of rotation, called the cam angle, is one variable that determines the displacement of the pump or the amount of fluid pumped per shaft revolution. Variable displacement units have the ability to vary the cam angle during operation, whereas fixed displacement units do not. As the cylinder block rotates, the exposed ends of the pistons are constrained to follow the surface of the cam plane. Since the cam plane is at an angle to the axis of rotation, the pistons must reciprocate axially as they precess about the cylinder block axis. During the rising portion of the piston's reciprocation cycle, the piston moves toward the valve plate. Also, during this time, the fluid trapped between the buried end of the piston and the valve plate is vented to the pump's discharge port through one of the valve plate's semicircular ports, the discharge port. As the piston moves toward the valve plate, fluid is pushed or displaced through the discharge port of the valve plate. When the piston is at the top of the reciprocation cycle, commonly referred to as top dead center or just TDC, the connection between the trapped fluid chamber and the pump's discharge port is closed. Shortly thereafter, that same chamber becomes open to the pump's inlet port. As the piston continues to precess about the cylinder block axis, it moves away from the valve plate, thereby increasing the volume of the trapped chamber. As this occurs, fluid enters the chamber from the pump's inlet to fill the void. This process continues until the piston reaches the bottom of the reciprocation cycle, commonly referred to as bottom dead center or BDC. At BDC, the connection between the pumping chamber and inlet port is closed. Shortly thereafter, the chamber becomes open to the discharge port again and the pumping cycle starts over. In a variable displacement unit, the cam angle is determining the amount of fluid pumped per shaft revolution. If the cam angle is set to 0, corresponding to that the swash plate is set parallel to the axis of rotation, there is no movement of the pistons in their cylinders. Thus there is no output. If the cam angle is set to maximum, the displaced pump volume and thereby the output will be maximum. If the rotation direction of the pump shaft is reversed with unchanged cam angle, then the pistons will move in the opposite directions, which will reverse their pumping action. This will lead to that the inlet and discharge ports will change place, which means that the flow direction of the pump will be reversed. Some pumps have the ability to move the swash plate over the center position. If this is done at the same time as the pump shaft rotation is reversed, then the piston movement and thereby the flow direction of the pump will remain in the original direction.